Hey guys, so I'm going to show you a review for your quiz that you have this week. I have a whole bunch of examples for you that will help you with your quiz that you have assigned. So this is all based on quadrilaterals and other polygons. Okay, so on number 1, our directions are to find the sum of the interior angles. So we have this figure right here. And we have this formula, n minus 2 times 180. N represents the number of sides of this polygon. Okay, so we got to count the sides. 1, 2, 3, 4, 5, 6. So it has 6 sides. And we want to find what is the sum of the interior. Sum means the addition of all the angles in the interior of the polygon. So 6 is going to be substituted in for n. So you have 6 minus 2 times 180. Well, what is 6 minus 2? 4 times 180. How much is 4 times 180? 720 degrees. So for a 6-sided figure, a 6-sided polygon, the sum of the interior angles is 720 degrees. So now this leads us to example 2, where it says find the value of x. Now this is a very strange shape, and we're going to look at how many sides this shape has. So we're going to count 1, 2, 3, 4, 5, 6. This also has 6 sides, which you already know that 6 sides equals 720 degrees. Okay, but we need to find the value of this angle x. What does this symbol mean by the angle? This means that this angle is 90 degrees. So in order to find out what x is, we have to add up all these angles, and it needs to be equal to 720 because this is a 6-sided figure. So let's add up all these angles. We have x plus 120 plus 97 plus 130 plus 150, and don't forget the box plus 90. And that all equals 720. So this is like an equation that you have here. So these are all your like terms that you're going to combine. You're going to add all these numbers up, and you get x plus 587 equals 720. From there, how do you solve for x? Subtract 587 on both sides, and you get x equals what? 133 degrees. And that's your final answer. That's what x represents, 133. So now we're going to move a little bit more forward on example 3 here. Find the indicated measure in this parallelogram right here. Okay, this parallelogram is called ABCD. ABCD. Okay, and we're going to find all the different measures of all 6 here. Okay, so let's look at what's on our polygon. We have our 2 diagonals, so I would say this is in the rhombus family, where you have 2 diagonals from AC to DB. They meet at a midpoint of E right here. Okay, they're stating that EC is 6, a measure of 6, and DE is the measure of 8, and you have this small little angle right here, which is 53 degrees. So we need to figure out the first one, part A, the measure of DAC. So DAC. So that means this piece. We need to figure out how much this is. Well, in the rules of rhombus with diagonals, if this side is 53 degrees, then the adjacent side of it from the diagonal is also 53 degrees. They're congruent. Let's go to B. We have to figure out what is AED. AED. Well, another rule for rhombus with diagonals. This angle, AED, when two diagonals cross, they form right angles. They form right angles. So how much is the measure of a right angle? 90 degrees. And that's finished. But now let's look at ADC. ADC. That's this entire angle right here. A to D to C. Okay? We need to figure out how much that whole piece is. But maybe we should first find out how much the smaller piece is right here. Okay? So if we know that this angle is 53 degrees and this angle is 90 degrees, how much can we figure out what this is? We have a small little triangle right here. Okay, so ADC is going to be 53 plus 90. And what does that equal? 143. Okay, so we have this 143. I should probably write this over here so we have more room. So we have 90 plus 53, which equals 143. Okay, so we need to use this and subtract it from 180 because the sum of every triangle is 180. So 180 minus 143 is 37. So this little piece here is 37 degrees, but we want to know the entire piece. So all we have to do is multiply this times 2. And we get 74 degrees. So the measure of angle ADC is 74 degrees. So those were the angles. Now we're going to deal with our segments here. Okay, DB, D to B. Okay, so this entire diagonal, if you know that this piece is 8 in this diagonal, then how much is this piece? This is also 8. So 8 and 8 gives you 16. Now they want to know how much is AE. That's this piece, AE. Well, you know that EC is 6, so how much is also AE? They're congruent. This is also 6. And then finally, the whole segment, AC. This piece was 6 and this piece is 6, so that makes it 12. And that's how you find those measures. Now let's flip over to the back. Now what we're going to do is we're going to find the value of x and y in this parallelogram. Okay, in a parallelogram, okay, you have two sides that are equal and they're also parallel, which also means is that this angle is equal to this angle. Now I'm going to work with these two angles because I can't work with these two yet. These two angles share an x. These two angles share an x and a y, and that's not going to help me. So what that means is if these two angles are equal, I'm going to set them up equal to each other. So we have 4x plus 13 equals 5x minus 12. And we're just going to solve for x. So I'm going to subtract 4x on both sides because I like to avoid negatives if possible. And we get 13 equals x minus 12. From there, I'm going to add 12 to both sides. And I get 25 equals x. So I found what x is. I found out what x is. Now I need to find y, but I need to use this x in order to find that y here. So if these two angles were congruent, that means these two angles are also congruent. So how do I set that up? I have this 3x minus 8 equals 4y plus 7. But guess what? I know what x equals. I can't solve this the way it is because it's two separate variables, but I know what x equals. So I'm going to plug that in. So we have 3 times 25 minus 8 equals 4y plus 7. Okay, which gives me 67 equals 4y plus 7. Subtract 7 on both sides. And you get 60 equals 4y. How do you get this y by itself? You divide both sides by 4, and you get 15 equals y. So you found x, you found y, and you're finished with that one. Moving on to our fifth example with a trapezoid. We are going to find the length of the mid-segment of the trapezoid. So here's our mid-segment of our trapezoid right here, and it's represented by 2x plus 4. Now we're not just going to find x, we're going to find the length of the mid-segment. So in order to find the full length of the mid-segment, we have to find x first. So remember, your mid-segment, okay, is always equal to these two divided by 2. Your two bases divided by 2. So your mid-segment, which is 2x plus 4, is equal to these two pieces added together divided by 2. So your first base, 2x plus 1, plus 3x plus 2. You're adding these two bases together and dividing it by 2. Well, we have a very long equation, but nothing we can't handle, and we're going to solve for x. So what we're going to do is I'm going to simplify the top of this a little bit better. I'm going to combine like terms so it looks shorter. So I have this 2x plus 4 equals, we have 2x plus 3x gives me 5x, and then we have 1 plus 2, which gives me plus 3 over 2. Now that it looks a little better, we need to get rid of this 2 that's connected by division. And how do we unconnect division? We multiply both sides by 2. So these cancel out. Now be careful here. You're multiplying 2 to this entire expression. So you have to distribute. So you have 2 times 2x, which gives you 4x plus 8 equals 5x plus 3. So now you have a nice basic multi-step equation. So we're still solving for x, so I'm going to subtract 4x on both sides. I get 8 equals x plus 3. And then subtract 3 to get x isolated, and I get 5 equals x. Now we're not done here. We know what x is. We want to know the full measure of this mid-segment of this trapezoid. So that means I need to take 5 and plug it in for x here. So I have 2 times 5 plus 4, which gives me 10 plus 4, which really equals 14. That is the final answer. And if you want, you can write 14 units, since there's no indicated measure there. Okay, so our last example below is we're going to find the indicated measures of this kite. Okay, now look at our kite here. The two diagonals that connect to the vertices of the kites are shown right here. Okay, which happens is that this side of this kite and this side of this kite are equal to each other, and these two segments of the kite are also equal. But when you connect these, intersect these two diagonals, they make a right angle. So if we know that these are all right angles, what is the measure of angle 1? Right angle is 90 degrees. That's already done. Okay. They told us in the diagram that this angle is 45 degrees. So if this side and this side are equal, that means this angle and this angle are also equal. So what's the measure of angle 3? 45 degrees. If we know that this is 45 and this is 90, how much is angle 2 in this triangle? Well, guess what? This is a special triangle. This is a 45, 45, 90 degree triangle. But let's just see how that would look. Okay. If you were to add all this up, 90, 45, and 45, does it equal 180? It sure does. So this piece is a triangle, this piece is a triangle, this piece is a triangle, and so is this. And now you found all 3 measures. So definitely review this video for your quiz assignment that I have posted for you. This will help.